Horizon Engineering Collective is proud to present to you the proposed extension of Dye Road, located in Ramona, California. Our team consists of myself, Aaron Gonzalez, Project Manager, John Hong, our Transportation Specialist and CAD Lead, Trevor Carter, our Geotechnical Specialists, and our two Stormwater Specialists, Olivia Brown and John Cabrera. Together, we represent Horizon Engineering Collective. In the existing condition of our project site, all vehicles traveling between Dye Road and San Vincent Road must undertake two tight 90-degree turns, posing significant hazards for approaching drivers. Thus, concerns regarding safety along this corridor have remained a frequent topic among community residents and in Ramona City Hall. Additionally, drivers approaching the movement are required to reduce speeds, ultimately slowing the flow of traffic and reducing efficiency. Correspondingly, plans for improvements have been implemented into the Sandag Routes 67-125 corridor study as an alternative 1B. Our firm proposes a new road segment that extends from the intersection of Dye Road and Ramona Street to Warnock Drive as a bypass to San Vincent Boulevard. This segment consists of approximately 3,500 feet of new roadway and the modification of existing roadway segments. Our design will implement a system with larger turn radii and increased stopping sight distances. Upon completion, the proposed improvements will allow for improved levels of service as well as driver safety. Additionally, drivers will also be able to maintain approach speeds of 50 miles per hour and travel an overall shorter distance to San Vincent Road with minimal adverse effects to the surrounding environment.
Hi everyone, I'm Trevor Carter and I'm the Geotechnical Engineer for the County of San Diego Dye Road Extension Project. The purpose of our investigation was to evaluate subsurface soil conditions along the project alignment and establish geotechnical design parameters and constraints. The results of the field, laboratory, and research studies were evaluated to develop conclusions and recommendations regarding an appropriate pavement design, soil mitigation measures, and other geotechnical considerations. A site reconnaissance was performed, and subgrade materials were sampled to depths of approximately 12 inches per City of San Diego Schedule J pavement standards. Approximate sample locations are shown in the subsurface exploration map. As can be seen, limited access confined the exploration to the opposite ends of the proposed segment. Bulk samples were obtained using hand tools and transported to a geotechnical lab for testing. Sample pits yielded reddish-brown silty sands with decomposed granite in each location. Visual analysis indicates that the samples from each end of the site were similar in composition. Therefore, our conclusions assume that the samples obtained adequately represent the subsurface conditions throughout the proposed development. Laboratory testing was performed for resistance values, or R values, per Caltrans Test 301, and results indicated an R value of 70. Traffic indexes for pavement design were calculated by extrapolating data obtained in Caltrans' annual average daily truck traffic report and applying a 3% annual growth factor. Additionally, traffic indexes have been selected per road classification in accordance with County of San Diego public road standards. Using our traffic and laboratory data, pavement sections were established using Caltrans Highway Design Manual. A 40-year pavement design life was required per HDM for all newly constructed road segments. Several pavement design alternatives have been provided for various scenarios to account for uncertainty in subsurface conditions. One of our designs includes a treated permeable base layer that should be implemented to promote drainage if further explorations encounter expansive alluvial material in the proposed right-of-way. Free drainage outlets have been designed to daylight beyond the surface asphalt layers as shown in the figure. Additionally, it is recommended that the drainage layers daylight prior to the proposed vegetated swells to discourage clogging by vegetation. One of the largest concerns regarding the underlying soil was the presence of expansive material. While we did not encounter the expansive material in our investigation, previous investigations in a nearby area discovered alluvium with an expansion index ranging from 80 to 87. Per California Building Code, the encountered subgrade material exhibits medium expansion potential. As such, Horizon proposed two alternatives for remedial grading if similar soils were encountered at our site. Alternative 1 proposes that expansive alluvium should be removed to a depth of 18 inches and replaced with non-expansive material, per City of San Diego supplement to the Green Book. Alternative 2 recommends stabilization by lime treatment to minimize strength and modulus loss due to moisture, as well as reduce swelling and shrinkage of expansive materials. The drainage properties of the soil and proximity to the site were obtained using USDA soil surveys. Soil information was then delineated and organized per basin using ArcGIS to be implemented into the drainage study. Data from the USDA Soil Survey indicates poor drainage characteristics in most of the areas relevant to the proposed developments. Soils underlaying the site are predominantly Class D and exhibit low infiltration potential.
Hello, this is John Cabrera. I'll be breaking down the hydrology and drainage considerations for the Dye Road Extension project. The San Diego County Hydrology Design Manual and Drainage Design Manual were the primary references for conducting calculations and deciding adequate drainage measures for the site. The rational method was used to determine the expected runoff to the site for a 24-hour, 100-year storm utilizing the county-provided isopluvial maps. Conservative estimates were used due to potential overflow from the existing reservoir adjacent to the site on the solar farm. A Q100 of 241 cubic feet per second was determined as a pre-project calculation. The existing drainage pattern for the site collects to a perennial creek, the Santa Maria Creek. This leads to an existing culvert on the other side of Ramona Street. One of the goals for the project was to have very low impact on the area, especially the existing drainage pattern. Maintaining the natural watercourse meant the road could not impede in any way. To mitigate potential redirection of the water runoff, a culvert is proposed to be placed where the creek runs. The analysis of the site post-project shows a conservatively calculated 305 cubic feet per second. The culvert was sized appropriately for the flow, and the conservative estimates were used again because of the potential overflow from the existing reservoir. The goal for the proposed drainage design was to do very little to what was already existing, and accommodate post-project runoff by maintaining what naturally occurs perennially. Thank you. Olivia will now go into more detail about stormwater management, and Trevor will discuss the proposed culvert.
The goal of our stormwater management was to control the quality of all the stormwater runoff that flows from the site both during and after construction. In regards to permanent structural BMPs, we designed a bioswale. Our bioswale has a 1.5-foot base and 3-foot shoulders with 2% slopes, leading into the 1-to-1 slope on the inside of the bioswale. The vegetation in the bioswale catches the pollutants in the stormwater so that the pollutants don't pollute the surrounding area. Our construction BMPs included a silt fence, fiber rolls, and stabilized construction entrance. In regards to erosion and sediment control, we chose vegetation stabilization planting for the disturbed slopes greater or equal to 5% and straw for disturbed areas less than 5% slope. The design considerations were based off of the 2019 County of San Diego BMP Design Manual and the Stormwater Best Management Practices Reference Guide. With the construction of the new road, the natural drainage of the site would have been interrupted. Since we did not want to interfere with the existing drainage, we went ahead and added a culvert on the northwest side of the site. The culvert is 197 feet long with a half a ton of riprap on each side. This allowed the drainage to continue as the natural drainage would have if Dye Road had never been extended.
As was stated previously, because of the poor existing geometry, the County of San Diego proposed a new alignment between Dye Road and Warnock Drive to improve efficiency and safety. However, the county's proposed alignment did not account for the impact to the existing solar farm in the area. Therefore, we proposed adding 2 horizontal curves into the alignment in order to avoid having to impact the solar farm and preserve the source of renewable energy. We used the Caltrans Highway Design Manual and the AASHTO Green Book for guidance when determining the geometric design of the new alignment. In order to preserve the existing design speed of 50 miles per hour and avoid having to impact the solar farm, we decided to incorporate 2 horizontal curves. According to the Caltrans Highway Design Manual, 1,175-foot minimum radius curves were needed with super elevation to counteract the centrifugal forces from taking curves at speed. Ultimately, 1,200-foot curves were used with an Emax of 12% and a super elevation rate of 9%. This allowed the cars to maintain the speed at a safe rate through the corridor. Vertical curves were not needed in the alignment because we were able to set the grades such that the difference in grades between successive grades was always less than 0.40%. This helped us when balancing our mass haul diagrams, and we were able to achieve a net earthwork of 1,000 cubic yards of export, and this would help immensely in saving costs and being able to use the existing cut in our fill areas. For construction, the construction of the project is going to be split into 2 phases. Phase 1 incorporates this plan set and the design of the new section of roadway with the horizontal curves and everything else incorporated in this plan set. Phase 2 would incorporate shutting down the existing roads and creating temporary detours and traffic control in order to demo the existing pavements and tie into the new section of roadway and also provide new driveways and access roads and fire access. Phasing out the project will improve safety and decrease the impact on the residents and commuters traveling the corridor.
Horizon Engineering has prepared the following cost estimate for the County of San Diego Die Road Extension Project. Our quantities are based on the construction documents and design drawings using Bluebeam and AutoCAD for quantity takeoffs. Values for pricing reflect estimates obtained from the County of San Diego unit price list, estimates for grading, typical values from the U.S. Department of Transportation, and various sources from online. The total expected costs for the project are approximately $2.4 million and $2.6 million after a 10% contingency. The 10% contingency has been applied to account for the unexpected costs and the following items excluded from the estimate: insurance and taxes during construction, permits and fees, professional design and investigation fees, inspection and testing, material removal, owner supervision, construction management, and overhead. One of the largest contributors to cost was the acquisition of land for the proposed right-of-way. As shown, several parcels were intercepted by the proposed alignment. Costs were obtained using the County of San Diego Assessed Values, Property Characteristics, and Maps website using ParcelQuest. Land acquisition accounted for approximately $700,000 or 25% of total costs.
Our studies have determined that all proposed improvements and mediation techniques are feasible and will adequately satisfy the project objectives. From all of us here at Horizon Engineering Collective, thank you.